Hello, and thank you for joining Getting Started with AWS Identity Services. I'm Mark Shalkevich, Principal Identity Go-to-Market Specialist with Amazon Web Services. I'd like to introduce you to identity in AWS. We'll review AWS Identity, the mental model, that is how we think about identity, AWS Identity in terms of identity, access, and resource management, access into AWS, that is, into the AWS cloud, AWS accounts, multi-account governance, and some tools and some additional services. In terms of identity, the mental model used by AWS is fairly simple. Who can access what? Looking at this model of who can access what, the who consists of name, credentials, and metadata. The can access is about the policies and compliance, and the what is about isolation, grouping, tagging, and sharing. Of course, governance across all three is also considered. For example, governance could determine if someone can connect an external IDP as an identity source, or have some level of guardrails around how resource sharing works, or perhaps to gather and present information on, that's right, who can access what. And the mental model of who can access what aligns to the identity, access, and resource management pillars. The who in our mental model from an AWS identity management perspective has two types of services, workforce and consumer services. Workforce identity includes several AWS identity services. First, AWS Identity and Access Management, as you may know it and people refer to it, IAM. Also, AWS Directory Service, which itself has several services under its naming, including AWS Directory Service for Microsoft Active Directory, which is a managed service used if you need an actual Microsoft Active Directory in the AWS cloud that'll support Active Directory-aware workloads, or AWS applications and services such as Amazon Workspaces, Amazon QuickSight, or you need LDAP support for Linux applications. Also under the Directory Services umbrella is AD Connector, and you use this if you need to allow your on-premises users to log into AWS applications and services with their Active Directory credentials. Now, of course, we have AWS SSO, which we'll discuss in further detail in a few minutes. For consumer identity, we have Amazon Cognito, which is used for high-scale SaaS applications when a scalable directory is needed to manage and authenticate subscribers that works with social media identities. This presentation predominantly focuses on workforce identity. I've talked about the AWS services for who, the identity pillar. Now let's cover the can access. AWS does this through policies. A policy is an object in AWS that, when associated with an identity or resource, defines their permissions. AWS evaluates these policies when a principal uses an entity that is a user or role to make a request. Permissions in the policies determine whether a request is allowed or denied, and actions on resources that are not explicitly allowed are denied by default. And most policies are stored in AWS as JSON documents. So AWS has different types of policies, and we'll highlight two IAM policies here, identity and resource-based policies. Identity policies focus on the user. In other words, they can be attached to a user, to a group, to a role to grant them permissions. The policy specifies what the identity can do to the resource. For example, a policy can be created to allow the identity to start an EC2 instance, but not stop it. Now, resource-based policies are policies that are attached to a resource, and they focus on which principal can perform an action on the resource to which the resource policy is attached. The most common use of resource-based policy is for an S3 bucket. For example, the resource policy can allow user 1 and user 2 to perform all actions on an S3 bucket, while any other users are not allowed to access the bucket at all. Both identity-based and resource-based policies are known as permission policies, and they are evaluated together. For a request to which only permission policies apply, as we're speaking about, AWS first checks all the policies for a deny. If a deny exists, the request is denied. Then it checks for each allow. if at least one policy statement allows the action in the request is allowed. It doesn't matter whether the allow is in the identity-based policy or the resource-based policy. There are also several other policy types, such as service control policies, or SCPs, which are a type of AWS organizations policy that offers central control over the maximum available permissions for all accounts in your organization. They define the guardrail permissions to AWS accounts, and a preventative guardrail ensures that your accounts maintain compliance because it disallows actions that lead to any policy violations. A session policy is an advanced policy that you pass in a parameter when programmatically creating a temporary session for a role or a federated user. And this is done via the AWS CLI or AWS API. Now, let's move to the what in the who can access what model, or the pillar we call resource management. Managing identities is just part of the equation. There's also a need to manage resources such as files, EC2 instances, satellites. We need to manage resources at cloud scale for hundreds of AWS accounts, thousands of Amazon EC2 instances, billions of Amazon S3 objects, trillions of Amazon DynamoDB items. Some customers have as many as thousands of workloads. Now, the challenge is the ever-growing number of resources. So your complexity may not be as high, but the point is that scale is going up and to the right, and this means that we need to have a more scalable way of managing resources that isn't always at the individual resource level. So managing resources at scale can be broken down into 3 steps. Find my stuff, which is find all the resources that belong to Project Blue. Organize my stuff, group all the resources that belong to Project Blue together, and manage my stuff. Allow only Project Blue developers to access the resources that are in Project Blue. This is known as tag policies, which can be attached to principles such as users or roles and to AWS resources. If the tag on the principal matches the tag the resource has, access is allowed. And AWS resource groups and tag editor can be used to add tags to or edit tags of multiple resources at one time. And with all that, the 3 pillars of identity, access and resource management, or the mental model of identity of who can access what, in putting all of this together, it provides us for fine-grained access control capabilities. Access can be controlled based on specific services, actions, resources, and conditions. So as an example, you can allow developers to use Amazon EC2 to launch new instances within a particular subnet and in an approved region and cost center. Now that we've completed talking about how we view the identity mental model of who can access what and the related 3 pillars of identity, access, and resource management through how they provide for fine-grained access controls, let's shift a little bit and talk about how to access AWS. The guidance is to start with AWS SSO, which you see represented with the icon in the lower left. AWS SSO is a cloud-based identity service that is essentially used for entry into AWS. It provides for central control of your workforce identities to all the AWS accounts you've granted them access to, as well as to AWS enterprise applications such as Amazon SageMaker or AWS IoT Sitewise, or to hundreds of SAML-based SaaS applications such as Slack, Jira, and ServiceNow. AWS SSO is tightly integrated with AWS organizations to help you manage access to user permissions and manage access and user permissions across all of your accounts. So for clarity, to use AWS SSO, AWS organizations is required with all features set to enabled. To access AWS, you can use AWS SSO's built-in native directory as your primary identity store, or quickly connect to and automatically sync with another workforce identity system such as Okta, Azure AD, or other third-party identity providers, as well as AWS-managed Microsoft Active Directory. You can protect AWS resources with consistent roles, with security policies, and strong user authentication mechanisms with multi-factor authentication as well. In short, what this gives you is one access control model, and you choose your identity source. In other words, we will meet you where you are. Now, using AWS SSO is as easy as 1, 2, 3, 4, 5. Or perhaps the slide should say, excuse me, 1, 2, 3, 1, 2. For AWS account access, choose an identity source, then define your role-oriented permission sets, and then you assign your users and groups to the permission set in selected accounts. For application access, you connect cloud apps with SAML and then assign groups and users to those apps. Here, we show that AWS SSO can connect to an external IDP, identity provider, such as Okta with normal SAML 2.0. As well, synchronization can be achieved by using System for Cross-Domain Identity Management, also known as SCIM. Of course, SCIM is optional, but it is highly recommended, and is noted in the slides to ensure that you synchronize your email attributes. Now, we've covered the AWS identity mental model, then AWS's services to implement that model, and a suggested way to enter AWS. Excuse me. Let's keep that in mind as we discuss an AWS account. Since we want to ensure your understanding of AWS accounts, what they are, and suggestions for how to use them. One of the ways in which customers can have both speed and security is by utilizing accounts. Customers sign up for AWS by creating an account, which is the management account. Then they start building resources and deploying services within that account as they build their environment. Accounts are essentially resource containers that assist users in managing AWS resources. They are explicit security boundaries, containers for cost tracking and billing, and they're a mechanism to enforce limits and thresholds, such as service quotas and API thresholds. As needs and demands grow, environments scale by adding new accounts. This is a best practice, so I'd like to discuss this just a little bit more. Scaling through account creation, that is using a multi-account model, is a best practice because it provides so many benefits. It enables rapid innovation across distributed teams and individuals. Similar to how customers can spin up EC2 instances in minutes, customers can create and provision new accounts and AWS resources for teams in minutes. You can deploy or adjust accounts to meet new business processes, such as when you need to define a set of workloads based on operational, regulatory, and budgetary requirements. Billing is incurred at the account level, so activity and costs can be identified with each account. And new accounts reduce the blast radius via isolation. For example, a potential bug in one account is contained within the account and cannot impact other accounts. In addition, accounts are natural resource boundaries, where access to one account does not cross over into others without first allowing permissions. It's worth noting that not all customers start with a single account. Some customers may migrate to AWS and set up multiple accounts to start, so they can achieve the same benefits we're describing here. And of course, with the use of accounts, we need to discuss how to manage them at scale. So let's talk about AWS organizations. AWS Organizations is a service that provides you with tools to centrally manage and govern your cloud environment. You can quickly scale your environment by creating accounts and allocating resources. You can customize your environment in multiple ways by applying governing policies. You can secure and audit your environment, and you can manage costs and identify cost-saving measures. There is no cost to enabling AWS organizations. AWS Organizations is a powerful tool because it allows you to manage your cloud environment while utilizing multiple accounts. This diagram represents a fully functional organization. The organization, outlined in red, consists of a single management account and multiple member accounts, which are grouped into organizational units, or OUs. Organizational units, shown here in the blue squares, allow you to group accounts by function or purpose. You can use OUs to develop custom environments for your users or teams by applying various policies at the OU level. In the diagram, you can see that we have separate OUs for infrastructure, for security, for a sandbox, and then a few others. There are also nested OUs in the security, infrastructure, and workloads, which allow you to separate your production accounts from your development accounts. This is a best practice as it allows you certain safeguards to be put in place to prevent unexpected issues with your production environment. Member accounts in the organization are noted with triangles at the bottom of the slide. This is just a high-level view to show you the power of centrally managing multiple accounts across an organization. It gives teams the space and permissions to manage their respective areas in your cloud environment while ensuring you take advantage of scaling and security benefits of multiple accounts. So let's ensure that we understand the benefits of AWS organizations. It provides native capabilities along with providing features for a number of AWS services to operate across accounts. And there are 4 main categories of features that AWS organizations unlocks for our customers. Centrally provision accounts and resources, share resources and control access to accounts, regions, and services, secure and audit your environment for compliance, and optimize costs and identify cost-saving measures. So there are a lot of customizations available for an organization, but I'm going to have a sip first before I get into that. So we want to go through 5 quick actions that any new or existing organization can take when getting started. Once you create your organization, we recommend you create your account structure, specifically your security OU and accounts. You can then enable security services across the organization, such as threat detection with Amazon GuardDuty, data security and data privacy controls with Amazon Macie, and configuration rules with AWS Config. You can activate the service at the organizational level and then delegate them to the security account that you created, which allows your security team to manage the services across the organization. The next step that most customers take is to deploy important resources, such as read-only role for your security team, into all the accounts using AWS StackSets. StackSets is integrated with orgs and can automatically roll out the required resources to newly created accounts. After that, customers tend to set overall policy for tags, backups, access, which are the SCPs, the service control policies that we previously discussed. Now, we have some governance rules in place. AWS SSO is a logical next step to start granting access to different user populations. Follow closely with AWS Resource Access Manager, also known as RAM, to share commonly used resources. AWS Organizations gives you the tools to build and manage your multi-account environment. But if you want to jumpstart your AWS environment with best practices and a very simple UI, in line with AWS Organizations, we offer AWS Control Tower. AWS Control Tower is built on top of AWS Organizations and provides an easy interface to assist building and achieving a secure multi-account environment, also known as a landing zone, with a predefined OU structure and default policies, which are also known as guardrails. It uses a combination of automated features from AWS Organizations, AWS Config, and other services to assist in maintaining these guardrails, blueprints, and account vending. The guardrails are the SCPs or config rules, the blueprints are OUs and the organization structure, and the account vending is the provisioning of new accounts and services. It'll abstract these services to automatically include the best practices we recommend for customers to manage their environment. We recommend Control Tower for newer customers who want a simple solution for building their environment. You can still use the underlying AWS services to customize or build your environment outside of Control Tower. And with that, we've covered the identity mental model, AWS Workforce Services supporting the model. We discussed how to access AWS, what an account is, how to manage and govern a multi-account model with AWS Organizations, and how to quickly build out that model with Control Tower. So let's talk about afterwards, when you're up and running. Customers tell us that they desire to grant their employees least privilege, which is the right access to the right things at the right time to do their job, but nothing more. But how do you know you're achieving least privilege over time? Typically, you have to widen permissions during development, but how do you know you can safely shrink permissions as you move to production? For this, we provide last access information, such as last access and role last used timestamps, to refine your policies and allow access to only the services and actions that your entities use. You can easily remove unused permissions with confidence. An access analyzer is a feature of IAM that continuously monitors and analyzes control policies to help teams centrally identify resources accessible from outside of an account. It's fast. It quickly analyzes thousands of resource policies in just a few seconds. You can analyze policies from S3 buckets, KMS keys, SQS queues, IAM roles, Lambda functions. It's the first service powered by automatic reasoning, and it's available to builders everywhere. It's comprehensive, so it's using mathematics to comprehensively to assess all access paths, not historical access to make predictions. All possible access paths are verified by mathematical proofs, and this is done via cognitive science called automatic reasoning or automated reasoning. You can use Access Analyzer to centrally analyze access across your entire organization, and it's available to you for free. Some additional good-to-know features for IAM Access Analyzer are policy generation, making it easier to implement least privilege permissions by generating IAM policies based on access activity stored in AWS CloudTrail. Policy validation, it supports over 100 policy checks to help validate conditions during IAM policy authoring in the IAM console with actionable recommendations to help you author secure and functional policies. Access previews enable validation of public and cross-account access before deploying permission changes, and it supports archive rules for new and existing findings. So let's summarize what we discussed. The AWS mental model of identity is who can access what, which is reflected in the identity, access, and resource management pillars. This is identity management, so use AWS SSO to manage user access centrally. Access management, policies to define permissions. Resource management, which are tag policies, and they're not just for billing anymore. And we discussed how to scale using multiple accounts. And we have AWS organizations which centrally control access, manage billing, share resources across your AWS accounts. And AWS Control Tower to set up and govern a secure multi-account environment. And we discussed least privilege. IAM Access Analyzer and role last used, reduce unnecessary permissions, and several other features that we just went through. And lastly, we want you to support building your own community of identity professionals. So you could reference the information we discussed on identity, IAM, single sign-on, directory services, organizations, control tower, as well as consumer identities with some of the links here on aws.com, WAC, and put in what you're looking for, such as organizations or Amazon Cognito. So you joined the AWS Summit to learn, and you can keep learning beyond the summit with resources from AWS Training and Certification for Security, which includes courses specifically on identity. According to Global Knowledge, IT decision makers report having the most difficult time finding qualified cybersecurity talent, so training has never been more important. We offer more than 25 digital and classroom courses for you and your teams around security, identity, and compliance, and you can also showcase your expertise by pursuing the AWS Certified Security Specialty certifications. So please visit aws.training/WAC Security. I'd like to thank you for joining me today. I had a great time speaking with you again. And I do ask you, please complete the survey for us.